Okay, so I am going to go ahead and delete all of this. And I'm going to add our goal. Sorry if you heard Al. He gets pissed at things very easily. Okay. Now let's walk through what we've just done to make more sense of the structuring subproof and then the nested subproof. And then we're going to flip it so that what is currently our nested subproof is going to be our structuring subproof. Hold tight. This is super fun and super exciting. Okay. Is everybody comfortable with the argument? Hey, kid, candy's in my left hand or my right hand. It's not in my left hand, so it's in your right hand. Now suppose that we say, I don't believe you. I don't believe you. It's not the case that candy is in your right hand. So notice what we're doing. We're saying that the conclusion is being denied. So one of the things that we're going to start talking about is how we use our conclusion to determine our strategy for proceeding. So look at the not are. Look at your negation intro rule. Does it make sense that our current framework, assuming not are, generating a contradiction, exiting the subproof, and introducing a negation, as I think it was Lewis who pointed out, there was a negation in the assumption, so we introduced a second one, right? Can you see that the negation intro rule maps on to this example? Yell at me if you can't. Okay. Now, when we're deriving the conclusion of a valid argument, we're going to use every premise that's given or that we have derived, right? So we will, if you will, discharge, make use of our each of our steps in the proof until we get to the termination of the proof at the last step. So let's go back to now our first premise. Our first premise says candy's in our left hand or our right hand. You know and I know that a disjunction is true in three ways. A disjunction is true when each of the disjuncts is true, or when one or the other is true, when at least one is true. When we're given a disjunction, we don't know which of those ways the disjunction is true. So what we do is we say, well, let's assume the left side is the case. We derive from that assumption the sentence that we want, in this case, the contradiction. Then we exit the subproof and we go on to assume the right side of the disjunction is the case. We derive the sentence that we want, in this case, the contradiction, so that we can get out of the subproof and say, look, from this disjunction, whether we say that we have the left side or the right side of the disjunction, in either case, we have a contradiction. Thoughts?
Makes sense to me.
Professor, do we have to do the subproof within the subproof? Like if we assume not R, and then we derive not L from the premise, wouldn't that negate the disjunction?
Right. So I think what you're asking, and forgive me, I'm looking at, hold on just a sec. This is annoying. I'm looking at something. Was that Mike or who just spoke?
Ivan.
Oh, it was Tyler. I'm sorry, Tyler. For some reason,
Ivan.
Ivan.
oh, sorry, sorry, Ivan. Okay. Wait, but where? Oh, there you are, Ivan. Okay. So I'm looking at my other screen. Okay. So, so Ivan, do me a favor. Ask the great question that you just asked again, because I'm sure that it's one that other people have, and it's one we definitely want to address. And I don't want my answer to sound snotty, but it might. So go ahead and ask the question again. I want to highlight where you are.
So since we're assuming not R, we could also derive not L from the premise, like right below it, and so we don't even have to do a subproof for that.
Okay. Are you saying that once we assume not R, we could infer L?
We could infer not L because of the premise on the second line.
So, no. Hold on just 1 second.
So we're basically reiterating not L?
Well, you could reiterate not L, but, so this is what I took you to say. I thought you were saying that if you have not R, you would infer L, you would dismantle the disjunction that way.
No, so right there I would put not L.
And that's just a reiteration of not L at line 2. Okay.
Yeah, and wouldn't that contradict the disjunction because it would be not L and not R?
Okay, so then what you're saying is this. You're saying that there's a contradiction between line 1 and 3 and 4.
Yeah.
Okay. So let's do this, and let's talk about this. I mean, I appreciate where your thinking is going. It's savvy. It's swift. But let's talk about this. So why are we getting the X? What's the issue? Well, let's talk about this comment at the bottom of the screen. This rule requires that 2 support steps be cited. So one of the things that we want to think about is this. The derivation is a complete dismantling of the relevant connectives. And so basically what we're being told is that if you say that lines 1, 3, and 4, or let's suppose that you, instead of so you can reiterate this, but let's suppose that instead you just did something like this, right? So 1, 2, and 3, right? You did the same thing again. Basically what Fitch is saying is you need to dismantle the connectives. That effectively what you're doing here is not demonstrating teeny tiny step by teeny tiny step how we get from premises to conclusion. You're doing something akin to what we see in the truth table, where the truth table shows the argument is valid, but it doesn't tell you how to get from the premises to the conclusion. Does that make sense?
Yeah, that makes sense.
So what Fitch, what we're doing when we generate a proof is we say, okay, we need to talk through effectively using our rules. So the snotty answer is, hey, what you just asked us to do isn't in our rules. The longer answer is the one that I gave you. And now let's talk about the teeny step by teeny step move. It's L or it's R, and it's not L. We said, well, let's assume that it's not R either. We know that we're going to generate a contradiction, which then tells us that the assumption is incorrect. That goes back to our indirect truth table, right? What we're doing in each of these steps is we're saying that at every moment that we try to, in this case, maintain invalidity, we run into a contradiction. Right? I'm thinking about that indirect truth table again. Right? Now, what I did just a moment ago is I clicked on the check verify proof. Notice that Fitch tells me that each of my steps and what is line 9, my final step right now, they're all truth functionally correct steps. But I haven't satisfied my goal. Why? Well, because I've said it's not the case that not are. And what I need to do is eliminate, so take a look at negation elimination. I need to eliminate my two negations. Truth functionally, a doubly negated sentence is equivalent to, so it's a tautologically equivalent set of sentences. My doubly negated sentence is truth functionally equivalent to the affirmative. Now I get my green check marks all the way down. Thoughts?
And also for so if you just, instead of doing double negation R, if you just put R, I think Fitch would understand what you're doing there, no? And just
yeah.
Yeah.
Yeah, so and this is Ivan again. Yeah, Ivan. So one of the things that Fitch lets you do is skip the step that we just made, which is introduce the second negation and then eliminate it. Now, if we want to be, meticulous, we would say, don't skip that step, right? Because I just finished giving you this elaborate discussion about, accounting for each and every teeny tiny move. But yeah, you're right. Fitch will let you do that. I prefer personally not to, but doesn't mean that you would be incorrect to move straight to the affirmative claim.
Okay, so you would prefer us to not skip that step?
Well, I prefer it for us, but if you have an example of what we see in front of us, where the assumptive step that is contradicted yields an affirmative, that's perfectly fine. You're not gonna be penalized for it. It's because you didn't do anything wrong.
Okay.
Okay, so is everybody comfortable with the fact that we've worked this proof by way of what's known as negation intro? That's our structuring subproof. That's our blueprint subproof. Now let's do the same thing. Let me see. Yeah. Now let's do the same thing using disjunction elimination as our structuring subproof.